welcome to everybody that's here for the presentation today. For all you guys as students, you are going to have to do this at the end of your admin track, so please listen, take notes if you have a pen, so that way you get an idea of what you're going to be doing. All right, so you can, after this is done, you can go back to your class, talk to your instructor, get some more information, whatever you need to go through that process. Welcome to all of you guys that are representative of your companies coming in. Thank you very much for joining us today with this presentation. These students, they go through a process of, at least up to this point, with A+, understanding the hardware side of things, and then they go into the network administration side, which is dealing with mainly Windows 2012 in our case, through this process. And there's a lot of information that they get throughout these, basically 6 weeks information. So we have to spend the last 2 weeks not only trying to build it, but also come up with a presentation and present this to you guys in a way in which you'll understand what's going on in there. So there's a lot of information. We can't exactly go into in-depth of every single little piece, but at least they get an understanding. Here's the basics of what you're going to need to know of going into an environment that they're going to start with. And then hopefully you guys will give them a little bit further with what they need to know from that point. So they've spent their time building the stuff, working together, trying to figure out what they need, what they don't need. Just because you learn this doesn't mean it's going to fit in every single situation. So they're going to have to determine what will work well for the environment they're building inside there. So I ask you guys, if you do have cell phones, please put it on vibrate mode or turn it off. So that way when they're doing a presentation, they're not going to be interrupted in that route. After we're done with this, after they're done with the presentation, we'll take about a 5-minute break, give all the other students a chance to get back to the classroom and give them a chance to catch their breath, and then they'll come back in and introduce themselves to you guys to get a better idea of who they are and tell a little bit about themselves and go to that point. All right, everybody good? All right, well, let's get started then.
Good morning. My name is Justin Thurston. I'd like to welcome the faculty, students, and distinguished companies for coming to our presentation today. Benjamin Franklin, with the discovery of electricity. Alexander Graham Bell, the invention of the telephone. Nikola Tesla, alternating current and electricity supply. J. Presper Eckert and John Mauchly, the first digital computer, also known as ENIAC. Without these very influential people and their inventions and discoveries, we would not be where we are today. Now imagine if these people had their research stolen. If they hadn't kept their research hidden and secure. We'd be celebrating their discoveries with completely different people, like Wade Wilson here. We don't want that to happen to you or to your business. Imagine, if you will, your business, big or small, and the employee on the 3rd floor is leaving for the day. Their job is very important, lots of sensitive information that needs to be secured, financial information, personal information on people and businesses that you don't even know that they have. They leave for the day. They close the door behind them. The door doesn't latch, doesn't lock, doesn't even pay attention that it didn't do it, and they just walk away. The security staff there that's doing the rounds doesn't even see that the door is not secured. It's not locked. Anybody can get in there to take that information that they hold dear for their company, for their business. Anybody, like this repair guy, just walk in there and just steal stuff. Well, with us, you don't have to worry about that. We are a clandestine security solution. We are the shield to keep you safe. We use third-party technology that's installed in your company that we monitor. That way you don't have to. We will call you or your security staff to let you know that that room, that door, is not secure. That is what we do. That is who we are. For the foundation of CSS, we have 2 domain controllers. On DC1 and DC2, we have Active Directory Domain Services, ADDS, and Domain Naming Service, DNS. We also have 2 member servers, both running DHCP and DFS, for fault tolerance. The domain controllers and member servers are patched through a private switch along with client computers for the employees. That switch will be connected to a router to allow the servers and client computers access to the internet for research and business purposes. As you can see, we have a lot of fault tolerance and redundancy, because if we can't take care of our own information, how can we take care of yours? We have a domain name of css.local. We're using a net ID of 192.168.1.0 with a Class C subnet. We chose the Class C subnet for future expandability purposes. Prime example, we have Misty down in Oklahoma City in our sales department. Hopefully we'll get that big contract we've been hoping for. We're excluding the tail end of the IP address spectrum, so we can use the first part of that spectrum to make available for client machines. Each one of the items listed on the diagram here will be discussed more in depth within our company by each one of my colleagues. Now, Cameron Leslie will discuss the domain structures.
Thank you, Justin. So let's say that you just hired new employees. You want these employees to be established in your domain. You want to protect your information. You want to share your resources between locations. You also want to protect your employees as well. So what administrative capabilities will make it so you can manage your entire domain? Nick will be installing Active Directory domain services behind me, and we'll be promoting the Active Directory to domain controller. As Justin told you about the bird's eye view of the network, I'll talk about the Active Directory and domain services. Active Directory domain services consists of subservices like computers and users, which Nick will talk about later, and domain services, which has many roles and functions within the network. A few of the roles that the domain services does is store directory data, manages communication between users and domains. It also includes user authentication and authorization. It also holds all the objects within the domain that contribute to the schema or the blueprint. By the way, objects are users, groups, computers that are all created within the domain. In Active Directory domain services, we are able to manage all of the above. In our network, we decided to create a domain rather than just keeping our network as a work group. A work group may work well if you have a small amount of employees and you just want to share those files and resources. But having a domain allows you to manage all of the files in a secure place, in a centralized location. So we created a domain with 2 domain controllers with Active Directory and domain services on each DC. This allows us to use fault tolerance in between the Active Directory and domain services. The Active Directory domain services will replicate between both DCs. The first DC is created, will be created underneath a new forest. When we create the second DC, we chose the option to add the second DC to the forest. So as our company grows, we can extend our domain and structure by creating a child domain based on the location. This is where we initiate trust between both domains. Now, a trust is where the domains can share resources between each domain and feel safe about it. It can be set up where there is a transitive or non-transitive trust. However, when you create that second domain, the two-way transitive trust is automatically already set up. There are several kinds of trust. A transitive trust is where it can be determined if the trust can extend outside the 2 domains. A transitive trust is automatically a two-way trust. I trust you, you trust me, and we'll share our resources. By the way, I also trust the domain you trust. However, a non-transitive trust is where the trust is only between the 2 domains and can't go outside the domain. Active Directory has all these services and many roles that allow you to manage the domain at a centralized location. Now, Nick is going to enlighten you on the Active Directory domain users and computers. Thank you.
Alright, good morning everyone. As Cameron said, my name is Nick and I'm going to walk you through our OU structure. So what you're looking at right now is the users and computers section of Active Directory. This is where our structure is going to sit. Since we haven't added it yet, all that you're seeing is the basic containers that are automatically installed whenever you install ADS. Now, to create our structure, I wrote a PowerShell script, and it's going to add all of our 55 employees. It's going to add the structure itself. our groups, and it's going to add our users to their appropriate group and OU. As you can see, it takes a while to write, but you can save that, and if anything happens, you lose all your information, you can simply rerun the script and everything's back right where it needs to be. So Cameron's going to go ahead and run that, but before we look at the structure for CSS, we have to understand why it's important to have it in the first place. It's in the name. It's an organizational unit. It lets you divide the company up the way you want. Going right along with that, this is where you're going to link your GPOs to the appropriate users and computers. Again, this is where organization is key, so that your GPOs affect the people you want and not the ones you don't. So Gabe will talk more about GPOs later. So let's look at our structure. So again, all of our users are already where they need to be because of the PowerShell script. I've kept the names for our OUs simple, just the base name of sales or IT. Now when we go to expand, say to Oklahoma City, we would make a separate OU for them, set up the same way as KC, as Cameron will demonstrate. And the groups, since we can't have a duplicate name for a group in the domain, we would simply put the name of the city in front of it, so OKC, sales, or IT. For usernames, again, I kept it simple. It's just the user's first name and their last initial. And if we ran into any problems with duplicate names in the future, we would simply add a number to front of it. As Cameron's doing right now, he's adding a user into the GUI. Imagine having to do that 55 times for every single employee. That's why PowerShell script is the way to go. Because it's 2 seconds, everybody's there. So with that, I'm going to give the floor to Chris, who will talk to you about DNS.
Thank you, Nick. As Nick mentioned, I'm going to discuss DNS and name resolution. Why is name resolution so important? Well, I don't know about anybody else but myself. Whenever I go online, want to do some banking, it's a lot easier for me to simply enter in wellsfargo.com. Then, try to remember 159-45-170-143. Or was that 139? No, I think it's 143. Let's give it a try. But what allows us to simply enter the name of a website or a machine that we're trying to access is name resolution. For our purposes, we decided to utilize an Active Directory integrated zone. This is installed whenever a Server 2012 is promoted to the domain controller. Another advantage to this type of zone is all your DNS information is stored as an Active Directory object. That being so, it can be replicated to every domain controller within your domain. When DNS is installed, you also have a forward lookup zone created. Or you can manually input one as Triton is doing at this time. Some of the records that you can find in a forward lookup zone are your host A record, which resolves host name to IP addresses. Your CNAME, which can create an alias, like for ourselves, we want to ensure that whether somebody types in css.local or clandestine security solutions.local, and they access the same IP, we would use a CNAME record for that. You could also find your mail exchange record, your NS record, and your SOA, or your start of authority, which designates the authority of the DNS for a zone. Another advantage to this type of zone is it allows us to utilize multi-master primary. What this means is that every domain controller within our domain that has DNS installed can modify our DNS. At that time, it actually becomes the start authority for that DNS until such a time as another domain controller should modify the DNS. The rotating of your SOA, as well as the ability for secure dynamic updates, also makes this a much more secure option for our organization. As Cameron mentioned earlier, when we do expand, and should we decide to add child domains within our organization, we could also use stub zones or borders to resolve any name issues between our child domains. And with that, I will be followed by Triton, who will discuss DHCP.
Thank you, Chris. My name is Triton, and I will be talking to you about DHCP. As my colleague Justin said earlier in the presentation, we have configured 2 DHCP servers of fault tolerance with a split scope of a 70-30 split. What is DHCP? Well, DHCP stands for Dynamic Host Configuration Protocol. It is used to help assist our devices with acquiring its IP address, its subnet mask, and its default gateway. As well, the word for default gateway is router. How does it work? It uses a process called DORA. And no, not Dora the Explorer. It stands for discovery, which is discovering the DHCP server from our devices. Offer, the offer of the IP address from our server to our device. Request, the request from the device to our server. And acknowledgement are the server acknowledging the device, the IP address, with our default release time of 8 days. So why do we use DHCP? Well, I would assume that anyone would not want to statically assign an IP address to every device on your network. It would take a lot of time and be very, very inefficient. And also, it's very centralized. It can be used by just one IT administrator to be managing on our entire domain. And it's also to use to minimize errors by minimizing the errors of statically assigning every single device for a network. Because humans, we can mess up quite a bit. We can accidentally set an IP address with 2 devices, which would be very problematic. So how do we set our DHCP? We have to configure a scope. For our scope, we configured a scope of 192.168.1.1 to 192.168.254. Within our scope, we have also configured exclusions. The exclusions for the tail end of our network is for our routers, our DNS, and our domain. And also configured within these scopes are our options, such as what I said before, the DNS to contact our DNS servers, the domain name to contact the domain, and our routers to connect to the internet. As you can see here, my colleague Chris will be configuring the split scope of our servers, which will be the set of a 70-30 split, and with a delay of 500 milliseconds, which will be about half a second. And with that, I will be followed by Mr. Brian Nixon to talk about routing.
Good morning. I will be discussing routers and how we use them in our company infrastructure. We are a small company, but what we wanted to maintain was a quality network setup that has the capability to grow with minimal effort. We chose to utilize a single primary router setup with multiple roles and features installed. And as you can see, Chad is actually going to set up our router with those roles and features as I discuss the various aspects of our router. Our goal is to provide continuous in-house support and network support for our off-site sales and marketing teams while providing internet access and security. So how do we do this? Well, first off, we have statically assigned our router's IP address into our DHCP server, as Triton went over earlier. This way, all the computers on our network know exactly where our router is located and the default gateway to get out to the internet. Every computer with an IP address is part host, part router, but we have chosen to dedicate a server to act as our router. This is what allows our internal network to gain access to the internet. If we take a look at our routing table, you'll see that we have our network destination, our net mask, our default gateway, and our routing metrics. So if we had multiple routers set up and we had the metrics, the lower the number would be the priority router that they would access to get out to the internet. At Clandestine Security Solutions, we have to be up and running 24 hours a day, and this means reliability and continuous access to resources. Without a router, we'd be unable to access resources outside of our network, and our offsite teams would be unable to access any resources inside of our network. So this is also why we've installed NAT, or Network Address Translation. NAT is what allows a device to assign an IP address inside a private network utilizing a publicly masked routable IP address. What's great about NAT is that internet requests happen so rapidly that most of our users have no idea what's going on behind the scenes. Basically, all the users inside of our network utilize the same public IP address, but their own individual private IP address. This is how we can use one public address or for hundreds or thousands of users and either statically assign their IP addresses or allow our DHCP server to assign them. With public IPv4 addresses slowly running out, NAT technology has allowed us to save on costs by not having to purchase multiple public IPs from our internet service providers. If for some reason down the line we wanted to change our ISPs, we could do so more easily by transitioning by only changing the external IPs of our network and maintaining the infrastructure of our internal IPs in our network. CSS is dedicated to our customers, and that means having 100% customer satisfaction. We know what it's like to require fail-safe or fault-tolerant methods of preserving our system. And what does this mean for us? Well, it means maintaining our own line of defense by keeping our own PCs up to date and in good health. So we've discussed how we allow our internal network access to the internet. So let us discuss how we're going to allow our users on the outside access into our local network. For starters, we have established RDP and reconfigured the port from a default of 3389 to a port of 40,000. We did this for security reasons. An RDP, or Remote Desktop Protocol, is a point-to-point connection dependent on TCP/IP that displays either the desktop or a single application on the user's computer. Our primary use for this is during on-site and off-site remote troubleshooting. Our in-house support can view and control a remote desktop session, sharing input and display graphics between two remote desktop sessions, giving the support person the ability to diagnose and resolve problems remotely. RDP gives the users the ability to delete, copy, and paste text and graphics between applications running on a local computer and a remote session. Like I said, in a small startup company like ours, our infrastructure needs to remain intact and fully operational as much as possible. So along with RDP, we've added in VPN functionality, which my colleague Chad Johnson will be going over next.
Thank you, Brian. You guys just heard Brian talk about RDP. He also talked about two other services. That would be routing and NAT. Those are used and installed using Windows Server 2012 R2, the remote access role. Another service that we can put under the remote access role is the remote access service. We call it RAS. RAS allows us to host a VPN, a virtual private network. Imagine, if you will, a secret tunnel burrowing through the internet. Well, your data is going through that tunnel and effectively hiding it from public view. The internet, after all, is a public network. It does this using a tunneling protocol. We had a couple choices we could have made. We chose L2TP, or a layer 2 tunneling protocol. It allowed us some basic encryption. More importantly, it allowed us to use a pre-shared key. For demonstration purposes, we chose Shield. If somebody else wants to VPN on our network, they're going to have the proper pre-shared key, but they're not going to get in. Why is this important? Justin earlier was talking about Misty down in Oklahoma City, working on a big sale. She's got a big contract, and it's pending, that she needs access to her sales folder on our network. If she can't tell to hide it, I need you to change your network policy settings and encrypt my information so I can get my work done. So we do it from our side. We set network policies. We try to keep it simple, here, CSS, and we attach it to some groups. Misty is part of our sales group. So we set a policy for our sales group where they have access from 8 a.m. to 8 p.m. We need it more than that. You might use all of that. If she tries to sign in at 10 o'clock, she's not going to be able to. She's not meeting the condition of that policy. Brian, however, if he wanted to get into there, he can do it any time, day or night. He's part of our IT admin group. We're going to assign permission for that group that allows 24/7 access. So you've got your tunnel, you have your pre-shared key, you have your protocols. How else are we going to get in? Well, you need ports. You have a port open to get into the network. And instead of leaving all of our ports open, which should be a problem with security, we chose just 10. We picked 10 because we didn't think we'd have more than 10 people at any one time trying to use the VPN. With control of our ports, with sharing passkeys or passwords, call it what you will, with our employees, and setting the protocols that we want, we're effectively managing data transmission into our network securely. When I talk about managing, I will give you Sean English. With managing, however, it's a fail-safe configuration.
For the importance of our operation within our environment, we have implemented a few fail-safe configurations. One of these configurations are two servers running Active Directory. We've implemented RAID 1. With this, we have two mirrored drives So if one of our drives should fail, we have another drive still running on server. For our two member servers, we've implemented a RAID 1 and a RAID 5. Again, the RAID 1 for the basic configuration and operating system. The RAID 5 we have for our users, files, and applications. The RAID 5 we have 3 drives with information being written to all 3 with parity bits. Should one of our drives fails, we can replace the drive with a new drive and use parity bits to rebuild our RAID. For our files, we've implemented EFS, or distributed file system. With this, we can access our shares throughout our Active Directory environment, with the roots themselves are like little links visible to the network that direct us to where the shares are themselves. In our environment, we have 2 roots, both of them on our member servers. For full redundancy, we implemented 2 full backups. Both these backups are on external drives, one at 430 and one at 8. Our 430 backup is sent with a third-party company to be kept in a secure off-site location. As for our 8 o'clock backup, we have kept in a secure location on-site. Next is security, I present the 8.
Hello, I'm Gabe. I'm here to talk to you today about security, as Sean just mentioned. One of the first things that we've done to secure down our network is to lock our end users out of things they don't need to be getting into and to control the environment that they work in. To do this, the first thing we've set file permissions and NTFS permissions. Sean will be showing you the NTFS permissions we have set for our administrators. They have full control over anything within their department. However, our end users have a much more restricted access. They can only access things within their own department, and they can only edit files that they created themselves. The next thing that we've done is to configure a group policy. Nick mentioned this earlier, but group policy objects, or GPOs, are things that we set within group policy to manage and control what our end users work in. We've blocked out command prompt and the run command to keep our end users from being able to get into programs and access files within their computers that they don't need access to. But we've filtered out all of our administrators so that they can use it for troubleshooting. Another policy that we've set is the password policy to control everything that our end users, control the passwords that our end users can set. They're required to have a 6-character minimum, and it keeps their account secure enough so that they don't end up with a password like 1, 2, 3. The other thing we've done is to give our administrators a fine-grained password policy. Because our administrators have a more restricted, more access within our domain, they have more sensitive files that they're able to get into and edit. We've given them a fine-grained password policy that requires that they have a much more secure password than the ones that our end users use. Sean will be showing you the fine-grained password policy that we've set, or something that we've set for administrators and for administrators. The final thing that we've done within our network is to configure a firewall. We've opened up all of our ICMP ports so we can test connectivity between our network computers. And we, as Brian and Sharon mentioned, configured ports, 10 of them for VPN and port 40,000 for remote access desktop. Thank you. And following me will be Justin to see Rob.
Hi again. Well, this concludes our presentation. I want to thank each one of my colleagues for coming up and describing everything that we have in our blueprint here. If you are interested in our company in any way, shape, or form, please, by all means, after this, give any one of us, myself, like my colleagues here, and we can introduce you to our sales department. Possibly even Misty if you're heading down to Oklahoma City. So, with that all being said, please join us in our break room for delicious sandwiches and drinks at our wonderful venue. This concludes our presentation. Thank you all for coming.
thanks everybody for coming. Hope you guys enjoyed the presentation. Got some information out of it. As you guys, students, you find a lot of information. You're trying to figure out what's going on and what we have to do, what we don't have to do, and so forth. So make sure you talk to your instructors, get as much information as possible. And one of these groups, and I'll see you guys in a couple of weeks, right? So you better be ready to go. All right, so it'll take 5 minutes. You guys come back to your classes. You guys want to do the break? Probably right after this.